let's look at this thing called contingency table or two-way tables. Okay. Um, and again, like I mentioned, contingency table is a way to organize information for two variables. And that's why it's called two-way table, that are both categorical or treated as categorical. It doesn't have to be categorical, but it's going to be treated like so. In a spreadsheet, you can create the table using an algorithm called a pivot table. So I don't know if anybody's messed with spreadsheets before, like taking a class in spreadsheets. Has anybody taken a class on spreadsheets? Like, no? Okay. So in it, they might encounter this thing called a pivot table. So Excel calls it a pivot table, Google Sheets calls it a pivot table, and in business it's called a pivot table. So it takes all your raw data and then turns it into this table. Okay, it summarizes everything into a table. So we usually consider some concept tied to probability theory, and which is used in statistics. If you take Math 244, you'll encounter these tables to establish a relation between variables. Okay, so that's the whole point of this. However, please understand we're going to use mixed language that is tied to probability theory and statistics. So we're going to do both. So contingency tables are tied to the language of probability. And two-way tables are tied to statistics. I hope I got that right. I always get them mixed up. Yeah. So like experiments use this a lot. And so does polling. Polling is another place where you see these tables prop up. For example, Chicago does this every year or every few years. The University of Chicago does this wellness survey across the United States. And what do? Like one of the things they ask is about if we have time, I'm going to show you where the site is. It's pretty incredible. But they've been tracking like happiness. Like, do you ever see in the news, like, what's the happiest country on the planet or the happiest city or things like this? You see once in a while. Well, it comes from sometimes these government surveys that they do. And the idea is to establish some kind of parameter to try to figure out how the citizenship is doing. But one that always cracked me up was the happiness scale. I think the ones that have won more likely the happiest country or usually is like either Sweden, Finland, Denmark. Anyway, those countries usually rate high on the happiness scale. All right. So again, our goals here are to be able to associate portions of the table with statements used in probability theory, which are building blocks of sampling, or again, in theory, how sampling works. All right. So a quick little thing here, categorical variables and variability. A categorical variable can vary in association with statistics and experiments. The variation values are called factor levels. So again, this is back to experiments. If you ever hear the word factor level, what are we talking about? Is that we're usually talking about a categorical variable, but the levels are how can that category vary? Okay. So even though categorical are not numerical, we still think of them as varying. Okay. In an experiment to determine if a person can be influenced by the surrounding environment, a person is brought into a room that has a particular subtle suggestive color in the environment. Okay. The person is asked to choose a color they find more pleasing. So notice in this case, what is the variable? Color. Color is your variable. And the factors can be, so notice what could be a factor level? A variation within the general topic of color. And if you have a color, what's the name of a color? Gray. Yes, it could be this, gray. What's another color? Blue. See how easy this is? One more for fun. What is it? Yeah, red. Okay, yeah, things like that, and so on. Okay, so then all of a sudden these are factor levels. The variable is color, but the factor level is okay. So how are we varying this, right? Maybe they only have a few colors that are going to be okay if we suggest something. So anyway, that's what that would be. So notice, let's look at a second example here. A pollster can call 100 levels, 100 local citizens to interview. One measurement that the pollster will measure is party affiliation. Okay, so notice in this case, what is the variable being measured here? Yep, exactly. Party. So it's pretty simple. It's a very thing that you party affiliation. And what are possible factor levels? Part and political, right? Sorry. Party by party, I mean not like, hey, what's your favorite place to party, but political party. Sorry, I forgot this little keyword here. Political party. And so, what are possible factor levels? It's so much funnier when people participate in this class. It just makes my life so much more simple. Yeah, so give me a party. There you go. Give me another one. What is it? Republican. Excellent. All right, let's see if we could get like the ones that are not so popular. You got the two big ones, but what are other ones? Progressive. Yeah, there we go. So we get like progressive. Yeah, there is a Green Party. Right, there's the Independent Party. Independent Party. There's also the Libertarians. There's definitely the None. Like I'm not associated to anything, and so on. Okay, so these are all the factor levels. Is how can this particular variable change? All right, great. Notice how let's use a quantitative variable. Can also be used in contingency tables and in experiments or poll data by limiting the data range or using data ranges. Okay, so the pollster that will call 100 local citizens will also measure the age of the participant. Okay, the age reported as belonging to a certain age range. So notice again, in this case, what is the variable? Age. That's right. Age is my variable, and I'll do this at factor levels. Typically, you'll see this all the time. They're really numerical, but we'll go 18 to 25 years of age, or then maybe 26 to so they just break it down into ranges, 26 to say 35 years of age. And of course, these don't have to be equal with, because they don't care. That sometimes what they do is they group this according to what they think is a more likely cohesive group. So maybe 26-35 is a cohesive group, and then 36 to 50 years of age is a cohesive group, and so on, right? And so on. I'll just do one more. 50 to 65 years is another cohesive group, and then usually 65 plus is the other one. Okay, so anyway, we take it and break it down into ranges, and then those become the factor levels. Okay. But again, notice it is quantitative, but what we've done is break it up into sort of a categorical viewpoint. So you can always take something that's numerical and turn it into something that's categorical, but the other way cannot be done. Something categorical cannot be turned into something numerical. It doesn't work the other way around. All right. One more here. In an experiment, the subjects are separated into 3 groups, each group receiving a different dosage of drug, 15, 30, and 45. So what's the variable? That's it. Drug dosage is my variable. And what's the factor levels? That's it. So again, another approach is that in like medicine, when we're doing these things, all of a sudden, these definitely as a numerical, but we're limiting what the number can be. So we, in a sense, think of it as now as a category. Okay, so that's another way of doing it. So again, I'm a firm believer in getting down to the specifics, the atomic scale, so you can see how things are. And then later, when you get the question, it's all kind of summarized for you. But you got to understand that it has to come from somewhere. It has to come at the most basic atomic scale to then start to summarize everything. So then you can recognize things. Right. And again, the reason I do this is because the only way to really to interpret information or summaries is to really think about what's the goal here and sort of have something in your mind that you know how it's being put together, the structure of something. Then once you understand the structure, the magic sort of goes away. If you keep this structure hidden, then math seems magical, and it's really not. It's just engineered.